Elon Musk has finally spoken out about the three ISATs, and his warning about a possible collision path is rippling through the scientific world and igniting social media across the globe. In a string of posts that spread rapidly, Musk, who has access to SpaceX's sophisticated tracking infrastructure and direct lines of communication with NASA, disclosed something the agency has not openly confirmed. Alice's trajectory has shifted. Based on Musk's analysis using SpaceX tracking data, the enigmatic interstellar object is no longer on a harmless flyby course. It is now following a path that brings it dangerously close to Earth's orbital lane, with a potential collision window opening in roughly 28 days. Musk was direct. The chance of impact is not zero, and it is rising. NASA is aware of this. They are withholding the information to prevent panic, but people have the right to understand what may be approaching. He followed these claims with SpaceX tracking visuals showing Atlas executing systematic course changes that have redirected its path by millions of miles. Adjustments that have steadily drawn it closer to a direct encounter with Earth. What makes Musk's warning especially unsettling is that he is not merely sounding an alarm. He has announced that SpaceX is already working on emergency response strategies, including possible missions to modify Atlas's trajectory or deploy defensive systems. When someone whose career is literally building spacecraft begins discussing planetary defense in real time, it demands attention. Before we break down Musk's trajectory analysis and explore why NASA refuses to confirm his claims, hit subscribe and smash like, because what you are about to learn about Atlas's collision course could completely reshape how you view the next 4 weeks. Musk has been labeled alarmist in the past, but when he is issuing collision warnings grounded in his own tracking data and supported by SpaceX engineers, dismissing it as hype may be a mistake. Let's look closely at what Elon Musk revealed about Atlas's trajectory, because the details are precise and deeply disturbing. According to information Musk shared from SpaceX's tracking network, Atlas has executed 23 distinct course corrections over the past 6 weeks. Each maneuver involved minor velocity changes of a few hundred miles per hour and trajectory shifts of only a few degrees. Yet taken together, these adjustments have shifted Atlas from a safe flyby route to one that intersects Earth's orbital zone. Musk posted detailed orbital mechanics calculations, showing that Atlas's original trajectory would have carried it past Earth at a distance of about 8 million miles, far outside any collision danger. But the combined effect of those 23 maneuvers has reduced the closest approach to roughly 180,000 miles, closer than the Moon. A SpaceX engineer involved in the trajectory analysis explained why this is alarming. When you observe systematic corrections that consistently shrink the closest approach distance, that is not random navigation. That is targeting behavior. Atlas appears to be steering itself toward Earth using deliberate, calculated maneuvers. The open question is whether it intends to pass by at 180,000 miles or whether further adjustments will bring it even closer. Musk's warning, however, goes beyond proximity alone. He pointed to a specific window 28 days from his initial alert when Atlas's projected position intersects Earth's orbital path. If current trajectory trends continue and additional velocity changes occur, Atlas could place itself directly in Earth's path with timing that suggests intentional interception. SpaceX tracking indicates that Atlas is accelerating at carefully chosen intervals to maximize gravitational assist from planetary alignments. This is advanced orbital mechanics, using planetary gravity to reshape trajectory while conserving fuel. Exactly the kind of planning used by spacecraft mission designers plotting efficient paths through the solar system. Musk underscored the precision involved. Atlas understands orbital mechanics better than we do. Every adjustment is perfectly timed to alter its course with maximum efficiency. This is not a comet drifting on inertia. This is a craft executing a complex navigation sequence, and that sequence is aimed at Earth. Musk also disclosed something SpaceX detected that NASA has not publicly discussed. Atlas's velocity relative to Earth is decreasing. Normally, objects on hyperbolic flyby trajectories speed up as they approach a planet and slow as they depart. Atlas, however, is showing velocity reductions that imply active braking, as though it is preparing to match Earth's orbital speed instead of streaking past at interstellar velocities. Musk's analysis included probability estimates that sparked intense controversy. He calculated a 12% chance of actual impact with Earth based on the current trajectory and observed maneuvering behavior. While 12% may sound small in planetary defense terms, any probability above 1% is considered extremely serious. For comparison, asteroid Apophis briefly carried a 2.7% impact probability in 2004, and that alone triggered global attention and emergency tracking measures. At 12%, Atlas represents a threat level roughly 4 times more severe, yet NASA has not initiated visible emergency response actions. Musk did more than issue a warning. He announced that SpaceX is already developing response options, and the scale of those proposals highlights both the gravity of the threat and the limits of our defensive abilities. SpaceX has reportedly been outlining mission concepts for rapidly deployable spacecraft that could rendezvous with Atlas and attempt to alter its course. Musk released early designs showing modified Starship vehicles outfitted for either kinetic impact or close proximity nuclear detonation, the two primary methods considered for deflecting incoming objects. The kinetic impact strategy involves crashing a spacecraft into Atlas at extreme speed to change its momentum. NASA successfully tested this method with the DART mission, but Atlas presents challenges that DART's target did not. It is much larger, is moving faster, and most importantly, it is maneuvering. Striking a stationary asteroid is difficult. Striking an object that can actively dodge is exponentially more challenging. A SpaceX mission planner involved in the conceptual work described the problem. We are essentially trying to design a mission to intercept and deflect something with superior propulsion and maneuverability. It's like attempting to ram a fighter jet with a slower aircraft. Even if we approach, Atlas could simply accelerate or alter course to evade impact. The nuclear option, detonating a warhead near Atlas to vaporize surface material and generate thrust that pushes it off course, appears more promising but comes with serious complications. First, it would require international approval to launch nuclear weapons into space, violating multiple existing treaties. Second, we do not know Atlas's composition or how it would respond to a nearby nuclear detonation. Musk addressed these issues bluntly. Treaties are designed for normal situations. This is not normal. If an object is on a collision course with Earth, we use every tool available. Treaties or not, violating space weapons agreements is preferable to watching a city be destroyed because of bureaucratic hesitation. The most revolutionary part of Musk's proposal involves deploying multiple Starship spacecraft as a gravity tractor, positioning them near Atlas, and using their combined gravitational pull to gradually shift its trajectory over time. This is the gentlest deflection method, but requires weeks and assumes Atlas does not resist or counteract the gravitational influence. SpaceX has reportedly completed preliminary planning showing that the first trajectory modification mission could launch within 12 to 14 days if approval is granted. That speed is remarkable, made possible by Starship's rapid reusability and SpaceX's launch infrastructure. Still, a 12 to 14-day launch window leaves little margin within Musk's 28-day collision timeline.